In lesson 4.3, we are going to be finding equivalent fractions. So let's start with the definition for equivalent fractions. Two fractions that represent the same number. You need to push pause and write that down. To find equivalent fractions, you're going to multiply or divide the numerator and denominator by the same number. So I'm going to put that here. Multiply or divide the numerator and denominator by the same number. So let's say we have a fraction, 10 over 30. There is an infinite amount of ways to do this. Okay, you're going to either pick multiplication or division, and you're going to multiply the numerator and denominator by the same thing. So maybe I pick multiplication. I'm going to multiply the numerator and denominator by 2. You always have to do the same thing. You can't pick two different things. So when I multiply by 2, I get 20 over 60. I can divide by 2. So divide the numerator and denominator by 2. I get 5 over 15. And I can go on and on and on and on. Your homework is going to ask you to find two equivalent fractions. This was the original, and I found two equivalent fractions. Know that my equivalent fractions might have been different than the equivalent fractions you thought of. So I'd like you to try this. Let's start with a fraction such as 1/2. Find two equivalent fractions. I'm going to choose to multiply by 2. That's nice and easy. And then even multiplying by 10 is nice and easy, because when I multiply by 10, really I just add a 0 at the end of each number. Okay, we're going to continue on this theme of finding equivalent fractions, but we're going to work with simplest form. Simplest form is when a fraction's numerator and denominator are relatively prime. Yesterday we learned, in the last lesson we learned that relatively prime is when you have two numbers and their greatest common factor is 1. Okay, so let's say we have 25 over 40. Our job is to find a fraction in simplest form when I have two numbers whose greatest common factor is 1. So I need to divide the numerator and denominator by the same number, and I want to kind of do this in one shot. This is the reason why we learned how to find the greatest common factor for this right here. Okay, some of you are going to be able to see the biggest number that you can divide by just by looking at this. That's great. But let's say you get stuck in a pickle and you're not sure which you can divide this number by. You can always use the greatest common factor to find the greatest number you can divide by. So that's what I'm going to do now. No, you do not have to use this process on your homework. You can just see the number in the back. But let me show you in case you get stuck in a pickle. So I am going to find the greatest common factor between 25 and 40, and I'm going to choose to use prime factorization. So I like the factor trees. Now I'm going to list out the prime factors. I'm going to start with 40's factors. And then 25's factors. I see that my full column, I only have one full column. So here the greatest common factor is 5. That means the biggest number that I can divide the numerator and denominator by is 5. So I'm going to write this down here. So this number is in simplest form because 5 and 8 are relatively prime together. They have no common factor besides 1. I would like you to try 27 over 42. And when you do this problem, I would like you to try using prime factorization. Even if you can see the number you can pull out of the numerator and denominator, this one problem, I want you to use the greatest common factor. Find the greatest common factor. Push pause and try that now. Okay, so first I'm going to use prime factorization. And then I'm going to list the numbers. Maybe I'm going to start with 27 this time. And here I have my columns. Even though I didn't draw the lines, they're there. My full column is this 3. So my greatest common factor is 3. That's the biggest number that I can divide these two by. So I'm going to divide by my greatest common factor. If you can't see what this is, it's okay to set up a division problem. There's nothing wrong with that. So 9 over 14 is in simplest form because 9 and 14, their only common factor is 1. Okay, so let me make a point here. You do not have to find the greatest common factor on your homework. Let's say you get a fraction such as 20 over 35. If you see that the greatest common factor is 5, you don't have to show all that work. I'm just going to divide these numerators and this denominator by 5. And I see that 4 and 7 have nothing else in common. I can't divide it by anything. So this is my answer, 4 over 7. We're going to be using the same process to simplify variable expression fractions. And again, that's why we learned how to find the greatest common factor. Let's say we have 16 BC cubed over 24 B squared C. You're going to want to break this into two parts. 16 over 24. If you can see the greatest common factor, go ahead and pull that out. If you can't, then you're going to use prime factorization or list the factors. I'm going to use prime factorization. List this time, I'm going to include the variables. Because I have variables, I am going to make columns this time, just to keep my thoughts organized. 16 is 2 times 2 times 2 times 2. And then I'm going to expand the variables. I have B times C times C times C. And then 24, doesn't look like I have enough columns. So we move this over. Columns. 24's factors are 2 times 2 times 3. So when you make your columns, each column represents a number. I cannot put 2 times 2 times 2. I cannot put 3 in this column because it already is represented by 2, so I'm going to put it in a new column. And then I am going to expand the variables. I have B times B. Again, I don't have any other columns with B, so I have to make a new one. And then I have 1C. Our greatest common factor are the full columns. So I have 2 times 2 times 2 times B times C. Remember, it's not 2 times 2 times 2 times 2 times 2 times 2. Each column represents 1, 2. So 2 times 2 is 4, times 2 is 8. BC. This is what I'm dividing this fraction by. Let me rewrite the fractions so we can see it down here. Okay. And I am dividing this fraction by the greatest common factor. Both the numerator and the denominator are going to be divided by 8bc. So start with the coefficient. 16 divided by 8 is 2. And then I'm pulling out a b, so there are no more b's. And I'm pulling out one c. If I have 3 c's and I'm dividing by 1 c, I have 2 c's left. 24 divided by 8 is 3. There are 2 b's. I'm dividing by a b, so we have 1 b left. C divided by c, just like 5 divided by 5 is 1, so the c's are gone. This fraction right here is its simplest form. I would like you to try one of these. This is our last problem. Simplify 36r over 6r squared x. Push pause and try that now. When I look at this, I like to look at the coefficients first. So really in my head, I'm thinking of this fraction. 36 over 6. This one's really easy to see the greatest common factor. The greatest common factor is 6, so I'm not going to go do my prime factorization off the side. I'm just going to go ahead and take this fraction and divide by 6. So 36 divided by 6 is 6. 6 divided by 6 is 1. So I know that my coefficients are 6 over 1. We don't have much practice with these variables, so my suggestion is at least find the greatest common factor between the variables. Because I already have the coefficients, I'm just focusing on this r over r squared x. And I'm going to find the greatest common factor, and I don't need to do prime factorization. I'm just going to set up this chart with the columns. So I'm going to list the factors of r and r squared x. R, there's only one r. Here I have 2 r's and an s. The greatest common factor between the variables is just r. So besides just dividing by a 6, here I'm just dividing by an r. So if I have 1 r and I divide by 1 r, I'm left with nothing in the numerator, just like 5 divided by 5 is 1, r divided by r is also 1. When I'm taking a r out of the denominator, I see that I have 2 originally, so I take 1 out and I'm left with an r and then this x. I'm just going to put these 2 fractions together. I have a 6 over 1 and 1 over rs. So I have 6 times 1 and 1 times rs. Okay, there's just another way of doing it. If you don't like that, you can use the greatest common factor method that I used in the first one.